Hi, my name is Mike Fossum. I'm the commander of Expedition 29. Welcome to the International Space Station. Today we're going to talk some about how the space station and other spacecraft manage to maintain their attitude in space. There's really two ways we could go about doing this. One way would be to use small rockets or jets, thrusters, to push the space station and keep it in the attitude that we want to maintain. The problem with using thrusters is that requires a lot of fuel, which we have to launch from the surface of the Earth up to the space station and keep it resupplied. We have a much more ingenious way. It's using angular momentum, or gyros, and that's what the discussion today is all about. Okay, so how do we use this then to control a spacecraft? Well, I about said it's easy, but it's not really a simple concept. We use systems called control moment gyros, or CMGs for short. It's an attitude control device that's used in controlling the orientation of spacecraft. The CMG consists of a spinning rotor and one or more motorized gimbals that tilt the rotor's angular momentum. Now, these gimbals are used to keep objects level in an unstable environment. As that rotor tilts, the changing angular momentum causes a gyroscopic torque that rotates the aircraft. Now, we have 4 of these CMGs, control moment gyros, on the International Space Station that control its orientation in space. The CMGs are steel wheels that spin at a constant speed of 6,600 rotations per minute. That means in 1 minute, the wheel rotates 6,600 times. Each CMG has gimbals, and these can be repositioned to any attitude or orientation. As the CMG is repositioned, that resulting force causes the ISS to move or twist. Using multiple CMGs permits the ISS to be moved to new positions or permits the attitude to be held constant. Now, on Earth, we can demonstrate this very easily with a wheel off a bicycle. Front wheel's usually the easiest. And it functions as a simple gyroscope. Spinning the wheel, once you get the wheel spinning, hanging on to the axle of the wheel, which is the axis of our CMG, and then you try tilting it, and you'll feel the very strange forces which are acting, not intuitive at all. You'll notice there's a friction that's increased and also that resistance. When you get that wheel spinning in a plane and you try to tilt that axis of rotation, the axle of the wheel, you can feel it definitely twisting in your hands. That's exactly the same force that we use to control the International Space Station. We can demonstrate some of these principles of a gyroscope in space, or what these control gyros do. I have here it's not rotating right now. The gyroscope inside here is not rotating, and I can float it here in space, and then I can give it a little nudge on the top and the bottom, and you see nothing unusual happens. I gave it just a tiny little nudge, and let me get it from the side here so you can see it from this side too. Again, the gyroscope is not spinning at this point. A little nudge on the top and the bottom, and it's very well behaved. It tumbles just exactly like you'd expect it to. That's because there's no real, the gyroscope itself is just a mass inside right now. It doesn't have any angular momentum itself right now. So let's get the string inserted into it and get this control gyro spun up to speed, and we'll watch the difference. All I'm doing here is wrapping this string around the axle of the gyroscope inside here. Okay, let's give it a good spin. Watch this. Okay, we've got a good spin going. Okay, there's some friction, so the frame, one, it's got a little wobble. Let's try to work that out. And then I'm going to give it that little push on the top and the bottom. It didn't start tumbling. Did you see that? It's holding it fairly stable. Let's look at it from the side. If I stop the gyroscope, I can get it to tumble like that. Now it's out of control. Before, with it spinning, It's exhibiting stability. There's friction and things like that in this. This is actually it's a toy. It's a demonstrator that you could make at home. And it's that friction that's causing it to really wobble and go a little bit unstable. But it's that righting force where it takes a lot more energy to get it to move once its angular momentum is set and it's turning like that. So let's sum up our exploration of angular momentum and gyroscopes. The angular momentum of a rotating object remains constant unless it's acted on by an external torque. Gyroscopes, which possess angular momentum, keep the ISS oriented and pointed in a favorable position. Take a look at the world around you and find other ways gyroscopes are used. Thanks for joining us on the International Space Station. Have a great day.